All right, so let's take a look at solving an equation by creating a linear quadratic system and using graphing to solve. So our next example asks us, how can you use graphs to find the solutions of the equation 5 minus x squared equals x plus 3? So what we're going to do is we are going to write that equation as a system. So we want to know when this 5 minus x squared is equal to this x plus 3. What that looks like on a graph is where those two intersect. So all we're going to do is we're going to split it up. We're going to take the left side of our equal sign and we're going to create an equation, a function out of that, y equals 5 minus x squared. And then we're going to take the right side of our equal sign and we're going to write an equation out of that, y equals x plus 3. So let's come over here and write that in. We have y equals, now this 5 minus x squared, I'm going to write that in proper order, so I'll just rearrange it as I rewrite it. The x squared, we want to write that first, that is negative, so negative x squared, and that 5 is positive, so I'm going to say plus 5. Right below it, I'm going to write the other equation, y equals x plus 3, and then I'm going to be fancy and put a little bracket around both, showing that this is now a system of equations. So we are going to graph this one, and then we're going to graph this one, and we're going to use the intersection point or points, or maybe there are no intersection points, to help us determine the solution to the original equation. So let's start with this y equals negative x squared plus 5. The x squared tells us this is our parabola, and the negative one, our a value is negative, so it's going to open down. If you take your x squared parabola and add 5 on the end, is going to shift up 5 units. So our vertex is at 0, 5, and then it is going to open down with a negative 1, negative 3, negative 5 pattern. So let's start by graphing that parabola. We said our vertex was at 0, 5. We shifted up 5 units. Now we'll go down 1 to the right 1, down 3 to the right 1, down 5 to the right 1. And let's get the points that are reflected on the other side. And the neater you draw your graph, the easier it's going to be for us to tell where the two functions intersect. Okay, well, that's kind of neat. I maybe could have done a better job, but we will go with it. All right, our next equation is the y equals x plus 3. So this is our linear function. This is slope-intercept form, mx plus b. So it's helpful to identify our information. Our slope is the number with the x, the coefficient of the x, which is a 1. So we have a 1 over 1 slope. And then the y-intercept is the 0, 3. So let's graph that. Y-intercept is 3. So I'm going to go up 3 on the y-axis and plot the point. Slope of 1, we're going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and then we'll backtrack and go down 1 to left 1, down to left, down to left. So we can already see that our linear function is crossing through the quadratic function twice. It is happening right here and right here. So the two functions intersect at those two ordered pairs. One of them is a negative 2, 1, and the other one is a 1, 4. So those are two ordered pairs where the two functions intersect. If we look at the original equation, 5 minus x squared equals x plus 3, notice the original equation has only x values. So even though I got an x and a y ordered pair and an x and a y ordered pair that are the intersection points, it's only the x values that are going to be solutions to the equation because the original equation had only x values. So the x values are the solutions. To the original equation. So we're going to say x equals -2 and a +1. Okay, we have 2 more. We're going to run through these a little bit faster. Hopefully you get the idea. And yeah, hopefully you get the idea. Let's take a look. All right, so what are the solutions to the equation? So part A, here's our next equation. First thing we're going to do is recognize that we can rewrite this as a system. We can say that y equals the x squared plus 1 and y equals the x plus 3. And then we put a bracket around to connect that as a system. All right, y equals x squared plus 1. That is a graph that has been shifted up 1 unit. So our vertex is at 0, 1, and our a value is a +1, so it's a 1, 3, 5 graphing pattern. So up 1 to the right 1, up 3 to the right 1, up 5 to the right 1. Get your reflection points and carefully draw in your parabola. All right, our second equation is y equals x plus 3. The y-intercept is a +3 and the slope is a 1. So we're going to start by plotting the y-intercepts. We're going to go up 1, 2, 3 units on the y-axis. We're going to draw in our slope points, +1, so up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. After you've gotten some points on that side, let's reverse, get the points on the other side. We can see that this line is intersecting our parabola in 2 spots. So we want to identify the intersection points. Here's one of them right here, and here is the other one right there. So the intersection points, oops, this first one on the left side is a -1, +2. And then the one on the right is +2, +5. And so the solution to the original equation, which has only x values, we're just going to take the x values from those intersection points. And we're going to say that x equals -1 and +2. All right, last one over here. We're going to solve this equation by graphing. So again, let's create or write a function for the left side of our equal sign. So y is going to equal that. And then let's do the same thing for the right. Y is going to equal that. We will write it off to the side as a system. So y equals, now I am going to write this in order. I want this x squared term first. So it's a -0.5x squared. And then that 5 is positive, so +5. The other function is going to be y equals -0.5x plus 2. And then we put our bracket around to show we are treating this like a system. Okay, so this -0.5x squared plus 5, this -0.5 is our a value. It's going to open down. It's going to widen our graph. This plus 5 tells us that our graph shifted up 5 units. So let's start by getting our vertex. We're going to go up 5 units and plot our vertex. Now our graphing pattern is going to be a little bit different. If we take that -0.5 and multiply it by 1, and 3 and 5, we're going to use a pattern of negative 0.5 over 1, negative 1.5 over 1, and negative 2.5 over 1. So it gets a little bit trickier to graph, but we can handle this. So we're going to go down a half to the right 1, down 1.5 to the right 1, and down 2.5 to the right 1. Let's get those points reflected on the left side, and then carefully draw in your parabola. So do you guys see how it is a wider parabola and it is opening down? All right, our next function, y equals negative 0.5x plus 2. 2 is our y-intercept, so let's plot a point at 2. And then the slope is a negative 0.5, so that's a negative 1/2. So our rise over our run, we're going to go down 1 to the right 2. So down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, backtrack, draw in your line. And we can see we have 2 intersection points. There's one right here and one right there. So let's just take note that these are intersection points. The one on the left side is a negative 2, positive 3. The one on the right is a positive 3, positive 0.5. But because our original equation had only x's, only the x's will be solutions to the equation. So x equals negative 2 and a positive 3.